All right, y'all, this is the third video. This is the back page, questions 9, 10, 11, and 12, all about law of sines and cosines and how many triangles can you make with the given information. Okay, so remember when we have this, one way to tell is by looking at your three sides. So we're always going to try and draw our triangle with this orientation. Putting the given angle in the lower left corner, right? The opposite side goes here and the adjacent side goes there. Okay, so we're given three pieces of information. We know the angle measure, we know the side across from it, and we know the adjacent side. That's the information that we're given. Okay, so here are your three things. One triangle. If the opposite side is greater than the adjacent side, right, straight away we know that there's going to be one triangle. Okay, one triangle and one triangle only. So you use the law of sines to calculate your one acute triangle. So this will always be an acute triangle. Okay. Now the other thing is, what happens if the adjacent side is greater than the opposite side? Which is most of the cases. If the adjacent side is greater than the opposite side, then we need to calculate the height of our triangle. Okay, and we always do that by taking the adjacent side and multiplying it by the sine of your angle. Okay, so that's going to tell us what the height of our triangle is, which will tell us some other things. Okay, so if the height is greater than the opposite side, then we have 0 triangles possible. Okay, also if you do the law of sines and we come up with an undefined, right, where you're finding an angle using the law of sines and you type it into your calculator correctly, right, as long as you're doing the math correctly, and you get an undefined answer, that also means that we have 0 triangles possible. Okay, so if you skip the step where you calculate the height and you went straight to doing the law of sines and your calculator told you that it's undefined, that means that there are 0 triangles possible. So the other option is if the height is less than the opposite side. In that case, there are 2 triangles. Okay, so the first triangle we solved, that's an acute triangle. So we're going to use the law of sines just like we normally would. Right, and this is the first angle that we find, is B1, okay, for your first angle, using the law of sines. And then your second triangle is always going to be an obtuse triangle, and this is angle B2. Well, B2 is always 180 minus the one that you calculated from before. Okay, so that's how we find the second triangle's angle, is by doing 180 minus the first triangle that you calculated. We don't use the law of sines again. We use geometry to tell us what that second angle is. Okay, so hopefully that is truly a review and not some fresh new information for you. So, how many triangles can be made with an angle of 41, an opposite side of, right, this is the opposite side. A is always across from angle A. That makes B your adjacent side. So if we want to draw our triangle, right, it looks something like this. Angle A is down here at 41 degrees. Side A is at 32 centimeters, and side B is at 45. Okay, so now we have to do our investigation. The opposite side is not greater than the adjacent side, right? Opposite is not greater than the adjacent. In other words, adjacent is greater than opposite. Right here, the adjacent is greater than the opposite, which means we have to calculate our height. Calculate the height. So that's done pretty easily. The height of your triangle is the adjacent side, which is 45, times the sine of 41. So 45 times sine 41, that is 29.5 degrees. Sorry, units, centimeters. So then how does 29 relate to 32? Well, it's smaller than it, which means there are two triangles possible. Okay, so if we were going to solve this one, we would use the law of sines and then flip over and do a geometry for that one. Okay, part B, here we have a 50-degree angle, right? C is the opposite side and 12 is the adjacent side. So 50 degrees, that's angle C. Side C is 14, side A is 22, so we can find angle A. Once again, the opposite side is smaller than the adjacent, so we need to calculate the height. So H is 22 times the sine of 50. So 22 sine 50 into the calculator, and I get a height of 16.8. So how does the height relate to the opposite side? Well, the height is greater than the opposite side, which means there are 0 triangles possible. Okay, when the height is greater than the opposite side, we can't form a triangle at all. And then part C, here we have once again your opposite side and the adjacent side. So here's angle B, right? 20 degrees for angle B. Side B is 18 and side C is 21. So we have to calculate the height because the opposite side is less than the adjacent. So 21 sine of 20. 21 sine of 20 is 7.18, which, as you can tell, is less than the opposite side. So this would also be a two-triangle situation. We can form two triangles with an angle of 20, a side of 18, and a side of 21. Okay, so let's see if we can apply that to our next three problems here. Calculate all the missing sides and angles for the triangle. These are law of sine and cosine problems. So the question is, which of our laws shall we use? Okay, and hopefully you know this is going to be a law of sine problem because we know the side and the angle across ratio. Okay, we know that the side of 14 is across from the angle 64 degrees. So this is a law of sines problem. So we're going to start with the proportion. 14 over the sine of 64 equals 21 over the sine of B. Right? 21 is across from B. So we can figure out what angle B is going to be. So we always solve these by cross multiplying. 21 times the sine of 64 and 14 times the sine of B equals 21 times the sine of 64. Next step is divide by 14. So we're dividing all that by 14. And then our third step is to move the sine over. And you always move the sine over by taking the inverse sine. So we're going to put this into our calculator. Inverse sine of 21 times the sine of 64 divided by 14. Anytime we find an angle, we're going to be using the inverse sine. 21 times the sine of 64 divided by 14. Undefined. So what does that mean for our problem? That there are actually 0 triangles possible. So this is a 0 triangle possible problem. In other words, this is drawn poorly, right? We can't actually have a triangle with an angle of 64 and an adjacent side of 21 and an opposite side of 14. Okay? So if that ever happens, right, because we didn't check at the beginning, that's your answer. or the calculator said undefined, and we interpret that as meaning no triangles possible. Okay, our next one. This is a side, side, side problem. And we find a side, side, side problem by using the law of cosines. Okay, the law of cosines involves only one angle. In fact, we're going to find the measure of the largest angle first, and the largest angle is across from the largest side. So here we have the law of cosines. We have 88 squared equals 44 squared plus 55 squared minus 2 times 44 times 55 times the cosine of b. Okay, so now we have to do a lot of algebraic simplification. So we start with 88 squared. That's 7744. Now I'm going to square these and add them together at the same time. 44 squared plus 55 squared. That turns out to be 4961. And then I'm going to do 2 times 44 times 55. That's 4840 times the cosine of b. Okay, we do our algebraic simplification when we're trying to use the law of cosines to solve for an angle. Now we minus the 4961. So 7744 minus 4961. That's 2783 equals negative 4840 cosine of b. Divide both sides by negative 4840. Okay, divided by negative 4840. Negative 0.575 equals the cosine of b. And our last step is to take the inverse cosine of negative 0.575. Okay, and when I do that, I get an angle of 125.1 degrees. We'll round up to one decimal place, 125.1. That's the angle measure for angle B. 125.1. Okay, so now we have some options to figure out everything else. We could use the law of sines, knowing that this is 125.1 degrees. We could use that ratio and set up a law of sines. That's a very good way to do it. 88 over the sine of 125.1 equals 44 over the sine of C, or we could have also done 55 over the sine of A. Okay, either way, we're going to use a law of sines to figure out what our other two angles are. Actually, one angle, and then the third angle we subtract from 180. Okay, so I'm going to pause the recording and solve this, and I'll be right back. I get angle C as 24.1 degrees. And then our third angle, angle A, is always 180 minus the other two angles. So angle A is going to be 30.8 degrees when I subtract the other two from 180.